In this video I'm gonna discuss chapter 16 of this book with a free online FEM tool or a free online engineering tool, and I'm gonna show you the calculation of a beam under distributed load. I've already done two videos on that, one with SolidWorks and one with Autodesk Force Effect, which is a free online calculation software tool. This one is as well. I'm going to show the advantage of this one, the engineeringcalculator.net, in this video, and also highlight the disadvantages. So when you combine them, you can get quite a good view of various calculations of beams with free online tools. So in the other two videos I've already shown, I'm going to calculate this profile, and here you see how to virtually cut a beam so that you can get an impression of the moment. So for this I'll also refer to the other two videos on chapter 16 of this book. And here you see the shear and moment diagrams, and I'm gonna generate those with help of the online free tool engineeringcalculator.net in this video as well. So here you see all the equations that are necessary to calculate the maximum moment, which is equal to the distributed load divided by 8 times the length to the squared. And here you see the equation that you can use to calculate the total deflection of a beam, and that's what the engineering calculator does and what the Autodesk Force Effect tool does not do. This tool does give you the maximum deflection of a beam, but on the other hand, Autodesk Force Effect allows you to create your own beam structure, whereas this tool, as I'm going to show later, does not give that opportunity. So here you see the calculation that is done. You have to pay good attention to the units to get the exact right results. Here you see the hand calculation version of the deflection that I calculated by entering all the values in this equation. And now I can show the online calculator tool. So I'm gonna choose a simply supported beam under a distributed load. I want to have metric units because that's what I calculated in, and then I need 100 kilonewton per meter, a beam of 1 meter, and point of interest can be at half a meter. And then I have got the right settings over here. I've already pre-run this calculation to get the right units. It's a 2.8, so it's in kilopascal, so you have to pay attention to that. It changes a factor from Pascal, a factor of 1000, so 2.1 E8, and here I can enter 3.49 and then E minus 6 like that, and then I can push calculate, and you see then the maximum deflection as calculated with this free online tool. It's a 1.7 millimeters, 1.8 millimeters actually, and here you see 1.78, exactly the same value. So check the other videos to see whether or not shear stress is also taken into account. It's a difference between a FEM analysis and a hand calculation, whether or not the shear of the beam is also taken into account, but that is highlighted in the video that I've done on SolidWorks simulation already. But you see here the displacement is calculated over the beam. You see the slope in degrees, which is normally not really that useful. At least I've never had a use for it. I can imagine other engineers will have it. Here you see the moment graph, and here you see the shear diagram. So it starts at minus 50 and ends at plus 50 of kilonewtons in shear. So that's the shear and moment diagram over here as well. But here you also see the deflection of the beam, and the shear and moment diagram I've already plotted it here. It's Q times L divided by 2 is the maximum shear, so you'll find that those values are correct. Also for that you can check the other two videos. I'm not gonna restate all the theory behind that for the third video, just to show you the difference between Autodesk Force Effect, this free tool, and SolidWorks simulation. So with some free tools combined, you can already do a lot of checking of your hand calculations, which is convenient, especially for engineering students. So thanks for watching.